All right, guys, good morning. I have the do now up on the screen. So if you want to take just a couple minutes, see if you can work through the do now. These are lab-based questions. So use your lab, specifically the calculations, to help you try to answer these questions. Use the table that I gave you. So in this data table, these numbers are probably different than what you had in lab, but use this data and see if you can answer these questions. So they should look fairly similar to the calculations that you did for the specific heat lab, but I wanted to go through it again because there were some questions yesterday on why there was, 1,000% error. So I just want to go through this and be able to kind of give you some helpful tips for the calculation. So take just a couple minutes, see if you can work through this, calculate the mass of water, temperature change of metal and water, and then the heat gained by the water. So use this data over on the side to answer these questions, and then we'll go over them in just a minute or two. Okay, so we'll go ahead and just kind of talk through the do now. I have the answers on the next slide so you can actually see the work for these do now questions. So for number one, you're calculating the mass of water in the calorimeter. So this data is just like the specific heat lab yesterday, just using different numbers. So in calorimetry, we have something in the coffee cup calorimeter, and then usually we're adding something else to it. So the mass of the water in the calorimeter, all we're going to do is we're going to take the mass of water in the calorimeter minus the empty calorimeter. So if we take the mass of water in the calorimeter minus the empty calorimeter, that will give us just the mass of water that's inside. So when you subtract them, and again, I'll put the answers up once we've gone through all of them. Once you subtract them, you do 77.7 minus 4.34. You should get 73.43 grams. So there's 73.43 grams of water in the coffee cup calorimeter. Then number two says calculate the temperature change of the metal. So 2 and 3 are two different calculations. When we're looking at the temperature change of the metal started out in the boiling water bath. So we made the assumption that by placing the metal in this hot water bath for 10 minutes, that the temperature of the metal would equal the boiling water. Now, that's not necessarily the best assumption because it could very well take longer than 10 minutes, depending on the amount of metal. But we made that assumption. So the initial temperature of the metal is 98.4 degrees Celsius. the final temperature of the metal is the same as the final temperature of the water that's in the calorimeter. That's 23.5 degrees Celsius. So remember, to calculate temperature change, that's delta T, you always do final minus initial, no matter what. So final is 23.5 minus initial, 98.4. You would get negative 74.9 degrees Celsius for the metal. And the reason that delta T is negative is because the metal cooled down. The metal went from being very hot to room temperature. And so since it cooled down, it actually lost heat, the delta T would be negative. So it's okay to have a negative delta T and a negative Q. M and C should always be positive numbers. So I think this is where some people got tripped up yesterday with the calculations. I was answering some of the questions yesterday. So for number 3, calculate the temperature change of the water. So this is the water in the calorimeter. So the water in the calorimeter started at 20.9 degrees Celsius and it ended at 23.5 degrees Celsius. So the temperature change of the water, delta T of the water, is final temperature of the water in the calorimeter minus initial temperature of water in the calorimeter. So 23.5 minus 20.9 gives us a delta T of water of 2.6 degrees Celsius. So this temperature change of the water calculation is, I think, where some people got tripped up on the calculations yesterday. The temperature change of the water is going to be very small. The temperature change of the metal is going to be very large. And we'll talk about why probably tomorrow. So then number 4, calculate the heat gained by the water. So heat is Q. So when we're calculating heat, we'll use MC delta T. So we use Q equals MC delta T. If it's for the water, that means we need the mass of water, the specific heat of water, and the delta T of water. So mass of water we calculated in number 1, that's 73.43 grams. The specific heat of water was given to you in the background information of the lab. That's 4.184 joules per gram degree Celsius. And the delta T of water we calculated in number 3, 2.6 degrees Celsius. So I'll just show you on this. We have 73.43 grams times 4.184 joules per gram degree Celsius times 2.6 degrees Celsius. When we actually look at all of these units and how they cancel, grams will cancel, degrees Celsius will cancel, we're left with joules. So for number 4, the heat that was absorbed by the water was 798.8 joules. The water absorbed heat, which is why Q for water is positive. And then number 5, what is the heat lost by the metal? Well, the heat that was absorbed by the water, we're assuming that there's no heat loss. So the heat that is absorbed by the water is equal but opposite in sign to the heat lost by the metal, because any of the heat that was absorbed by the water had to be lost by the metal. So for number 5, we'll just say negative 798.8 joules. Right, so here are all of the answers with the work for the do now. Again, this was to help hopefully clarify any information on the lab, especially the difference between calculations 2 and 3. So after you have the heat lost by the metal down here, here's Q of metal. You can actually plug Q of metal into MC delta T and use all the information for the metal. So, you know, you'd have a negative Q for the metal, your mass of your metal is from your data table, your delta T of your metal, you calculate in the calculations, and then you can use that to solve for C, which is specific heat. So the whole point of this lab was to solve for the specific heat of the metal. And your class solved for the specific heat of lead. And then you can look up what the specific heat of lead is and see what your percent error would be. Okay, so I wanted to go through that again, just to hopefully clarify any information on the calculations. If you made a mistake on the calculations, just use a single line, draw through it, and then just go ahead and work on your calculations underneath. Remember, for the lab, just another quick thing, there is no data analysis. So do the calculations, do the post-lab questions, and then go right to the conclusion. No data analysis. That's a big long paragraph where you're talking about your results, source of error, things like that, because the post-lab questions already tie in sources of error. Okay, any questions on the do now before we go on to what we're going to work through today? I don't see any in the chat, but I want to give you guys just a second in case there are any other. If you think of any at all, you can ask in the chat or like unmute once we start working. All right, so then for today, we're gonna actually just do today what those that were like supposed to be at home for this lab we're going to do. And that is watching the next 2 videos in the thermochem unit. So I want to give you like this class time because they're a little bit longer videos. They have lots and lots of examples built in to the video, which is why I want to give you guys this class time. So instead of making it homework, I want to just give you this time in class, watch the videos, take notes, see what questions you have. So you'll watch video 2.3. It's been linked in Google Classroom. It's in Edpuzzle. So you can go through, continue to ask questions in Edpuzzle. You guys are asking great questions at the end of the videos. So just continue to ask any questions that you have, and then watch video 2.4. So video 2.4 is a little bit longer because there are lots of examples built in. 2.4 is where we really start to get into the math. So tomorrow we'll be doing even more examples based on these 2 videos. Video 2.4 does reference Appendix C. So I put the link to Appendix C. I'll share this in the chat as well. I have Appendix C copied for you on colorful paper at school. It's in the top tray right now waiting for you. And so I have it copied. You don't have to worry about printing it out. If you want to print it out so that you have it, that's okay. But I do have it copied for you already at school because we will be using it often. But I do reference Appendix C, so I want you to be able to have it to at least look at it so you know what I'm talking about. And then after watching both of the videos, you can work on mastering, you can work on the post lab. If you want to like get together with a partner virtually and work through mastering or work on post lab, that's fine. Just like yesterday, I'm going to stay on this Google Meet the entire time. So I'll be on this Google Meet until 9:05 so that you can ask questions you might have, whether it's questions on the lab or you're done watching the videos and you're working on mastering. But I'll be on here so that I can answer whatever questions you have. The biggest thing is that you want to watch both of the videos during this class time. You don't technically have any homework. So you'll notice that like behind me, I have the like the schedule, kind of like I do at school on the board. The only homework is just to continue working on the post lab that's due Monday and then start working on mastering. So there's no additional videos to watch, anything like that. A couple reminders as well. The Westinghouse nomination form is due this Friday. So I know that I've had some people already fill it out. The only thing you have to do is have your parents sign a release form. So if they want to take pictures, you give them your permission. But that's due Friday. That release form is linked in the nomination form. You can print it out and just email it to me if you want. And then SNHS applications are due Thursday the 22nd. So that's next Thursday. And they're a little bit different from the NHS forms in that you're just writing a teacher recommender. You don't have to have them sign it. I've been getting that question a lot too, like how do we have teachers sign it? You're just gonna, email them, make sure it's okay that you're using them as a recommender. And then I will email them separately with all of the information. Okay, so here's what I'm gonna do. I'm going to put in the link. Yes, mastering is due in 2 weeks. So there is still lots of time for mastering. It's broken up by video, so you can work on it little by little. But I always like giving you time for mastering. Once we start doing the examples tomorrow, that's calorimetry, things like that, you'll be able to do a lot more of mastering. But there are some questions you could do right now. But yeah, it's due in 2 weeks. So I just put the Appendix C link in the chat. I can put the Westinghouse and SNHS links in the chat as well. Let me just close out of presentation mode. So I'll put these links. Westinghouse is, Ashley, I'll answer your question in a second. Westinghouse is the first 20 people that sign up are automatically accepted. Anyone after that will be put on a wait list, and then Westinghouse will let me know how many extra people we can send. And then Appendix C. So the AP test won't give you all of Appendix C. They will pull out parts of Appendix C and put it right on a test. So when we work through some practice with using Appendix C, I'll show you examples of what a question would look like on the AP test. So although you're not going to get, it's almost better that you don't get this entire thing because it might be a little overwhelming, but they will pull out the specific parts of Appendix C that you will need for the specific questions. So I put the Westinghouse and the SNHS links in the chat as well. Again, those are purely optional. You don't have to do them. But I always want to, share the information out. So you now have time. You can watch video 2.3, 2.4, take notes, ask questions in Edpuzzle. After you watch those videos, come back and ask any questions that you have. If you don't have questions, you don't have to stay on this Google Meet. You can leave the Google Meet and just jump back on whenever you have questions. You can unmute or just type in the chat, whatever works best for you guys. But you now just have time to watch the videos.